Okay, so let's talk about graphing polynomials. Let's see. First, let me draw just kind of a generic polynomial, just so I can identify some pieces and parts that we're going to talk about in depth. So, for right now, I'm sure you know what these are called. Right? These are the x-intercepts. We talked last class that x-intercepts have other names. They could be called the zeros, they could be called the roots, the solutions, and also loosely the factors. The other thing that we have, and also I want to point out that there can be multiple. That are possible. In fact, the number of x-intercepts directly corresponds with the highest power, the leading power of the polynomial. Now we have to take in consideration as we get closer to the end of this chapter that there will be some imaginary numbers that come into the play. But right now, if you have a polynomial to the 5th power, you're going to have 5 intercepts. The next thing that should be noted is this other point here. It's called the y-intercept, and there's only one. In fact, it's one of the things that defines something as being a function, is that for every value of x, there's only one value of y. And if we were to have 2 y-intercepts, then that would mean for when x is equal to 0, y was equal to 2 different values. So that is not possible. The other thing I want to point out, which is kind of new to you, would be this. This is called the extreme end behavior. And the cool thing about polynomials is that they always behave the same at their extremes. So different things can happen in the middle, but what happens on the extreme ends are always going to be consistent. And so let's talk about that. So here I laid out some more detailed information on the x-intercepts and the y-intercepts, and one of the main things I'm going to point out to you that is intercepts are points on the graph, and I want you to make a big habit of writing them as points. So I make a point. Make a point of that. I've lost my pen somewhere. Let me see. Okay, I found it. So here, x-intercept should be written as the number, comma 0, y-intercepts as 0, comma the number. I also point out that there could be multiple x-intercepts, but there can only ever be one y-intercept for the reasons which I just explained. And then I want to talk about a little bit about this extreme end behavior. And I'm never going to learn when I make PowerPoints not to put anything over here in this corner, because I'm always going to overstep that. So I'm going to draw one more in right here at the beginning. Okay, now you see I have 4 Cartesian coordinates here, little graphs, and that's going to indicate to you that there are only 4 possibilities of extreme end behavior. The first one is that both ends point up, and this would be considered even positive. Now, where we find the extreme end behavior from is looking at the highest power of x in the problem, determining if that is a even or odd number, and also we look at that leading coefficient and determine whether it is positive or negative. So here this guy is even positive. The next one, where both ends go down, would be even, negative. Can't spell this evening. Additionally, when we have the left side down and the right side up, that is called odd positive. The way you can remember it is in a positive direction is as you look from left to right, it's going uphill. And so that lets you know that it's in the positive direction. That's the same thing as when you're looking at linear equations, at lines. You can look at a line and decide whether the slope is positive or the slope is negative, depending on when you look at it from left to right, whether it is increasing or climbing up the y-axis or decreasing or going down the y-axis. And then finally, we have here, if it is up on the left and down on the right, that is odd negative. Okay. All right. So let's put all of this together with our first example. Let me write our equation up here. We're going to start off with f of x is equal to negative 1/2 times x plus 4. I lost my pen again. X plus 4, x minus 1 cubed, and an x plus 1. Okay, so we're going to graph this guy, and first off, let me say that I know that you have a calculator in your hand or on a computer at your fingertips that can do all of this graphing. But it's super important for you to be able to quickly sketch a graph and understand the key components of a graph. And the best way to do that is to do it by hand. And so that's what we're going to do. Now, I've got some steps over here, and the first step is to factor your polynomial completely. Now, I'm starting off with one that's already factored, but we'll have some examples later on that we'll have to factor. But let's not get caught in the weeds of factoring right now. So this guy is already factored. And what are the key components? Well, there are 3 things that we need to have for graphing polynomials. In fact, 2 of those things we need for graphing anything that we're graphing, whether it's an exponential, a logarithm, a quadratic, which is a kind of a polynomial, a cubic, which is a polynomial, logarithmic. All of these things you have to always have x-intercepts and y-intercepts, okay? Now, when we find x-intercepts, we're basically setting y equal to 0, which is also setting each factor equal to 0, which is why you should go ahead and factor it first. And then finding the y-intercept is just letting x equal 0. So let's find these things here. So for the x-intercept, we have x plus 4 equals 0, so x is equal to negative 4. So we have the point negative 4 and 0. We have x minus 1 equals 0. Notice I don't care about it being cubed. We're just going to take the factor part. It doesn't matter if the factor is raised to a power. We're just going to take the factor part and set it equal to 0. So we have x is equal to 1, so we get 1 and 0. And then finally we have x plus 1 equals 0, so x is equal to negative 1, and we have negative 1 and 0. We also need to find that y-intercept, and the way to find the y-intercept is to just plug in 0 for all the x's here. So y is going to equal negative 1/2 times 0 plus 4 is 4 times 0 minus 1 is negative 1 cubed. We do care about the powers now because we're evaluating the function. And we have 0 plus 1. So this gives us negative 1/2 times 4 is negative 2 times a negative 1 gives us positive 2. Our y-intercept is 0 and 2. And then finally, we need to find the extreme end behavior. And there's 2 questions that we ask. We want to know even or odd, and we want to know positive or negative. So here we need to figure that out. Now, We can't just look at the problem. We need to determine if we were to multiply this out. Do not multiply it all out. But if we were to multiply this out, you should be able to tell what the highest power of x is going to be. Now you can do that by simply counting all the x's that you would have to multiply together in those binomials. So let's take a look here. Here's 1x. Here are 3 x's because it's cubed, and another x. So we have 1, 2, 3, 4, 5. The highest power, the degree here, is 5, and 5 is odd. And then we'll look at this leading coefficient here and see that it is negative. So we have an odd negative, and that means that it's going to be up on the left and down on the right. Okay, now we have all of our information. We needed to find information on 3 things since it was already factored, so here we go. Now we're going to graph this, and again, this is a sketch. Please don't try to be perfect with this. Now, of course, you're doing this on your computer, so it's going to force a little bit more perfection than I'm going to be, but you don't have to be completely perfect here. First things first, it says plot the intercepts. So we're going to have -4 and 0, -1 and 0, and 1 and 0. So let me just put a few little hash marks here. Let me do some here. Now don't get too crazy because these can get a little bit crazy. Now let's plot our x-intercept here. So here's our -4 and 0. We also have -1 and 0, and we have 1 and 0. So those are our 3 x-intercepts, and let me put our y-intercept in there, and we got our y-intercept to be 0 and 2. Now the next thing we need to do is we need to sketch in our extreme end behavior here, and we see that it is odd negative. So what we do is we go to the leftmost intercept, where this is going to come off of our intercepts. So we're going to go to the leftmost intercept, and it says that we're going up. Then we go to our rightmost intercept, and that says that we're going down. Again, don't worry if your graph looks janky. Mine's going to look a little bit janky. Okay. Now, so we have plotted our intercepts, and we've sketched in our end behavior. Now we need to do a little mini sketch around the intercepts. Now here's something that I hadn't talked about yet, but I'm going to now. So notice up here, these are the powers on the factors. So if the power on the factor is even, the graph bounces off. If power is odd, the graph passes through. Okay, so if we look here at x is equal to -4, there is no power there. That means that it is the power of 1, which is an odd number, so that means that it's going to come down through here. Now at -1, I mean, the power is 1 as well, so it's going to pass through, so it's going to go through the point. At -1, or at x is equal to, or at the intercept 1, 0, so sorry y'all, That is also going to pass through. Now, we can connect the dots here because there is a dot to connect. So here we could just connect the dots. But here, there is no point to connect. So we must find one. Okay? Now, this doesn't mean that you have to find the exact point that's precisely between -1 and -4. It just means you need to find a value between -1 and -4 and figure out what that function value is. And I'm just going to find f of -2. Okay, so I'm going to plug in f of -2. Just like I plugged in 0, I'm going to plug in -2. So I have -2 plus 4 times -2 minus 1 cubed times -2 plus 1. And when I do that math here, let's see, we have -1/2 times 2 times -3 cubed times -1. That gives us -27. Let's see what we got here. -27 times a -1 is +27 times another -1 is -27. My goodness. Now, I don't expect you to draw this all the way down to -27, but what I do expect you to do is to do something like this and put in the point, come down and connect it, and then somewhere along here indicate that this is -27. Okay, now what your online homework is going to require you to do might be something a little bit different. It might just ask you what the value is and not have you graph it necessarily. Again, I typically teach this class not online, and I give paper and pencil exams in class. So I'm going to teach it to you the same way I would teach it if this was a face-to-face class. Okay, so, and there it is, our very ugly graph. And it is very ugly, without a doubt. That's okay. All the pieces and parts are there. Okay, so let us look at another one. Again, I'm going to start off with one that is nicely factored here just to make sure that we get the idea of all the little pieces and parts that we need to do here. X plus 2 and x plus 4. Okay, so here's our equation, and we need to get our x-intercepts. And we get our x-intercepts by going factors equal 0. So here we have x minus 2, so we have 2, 0. We have x plus 2, so we have -2 and 0. And we have x plus 4, that is -4 and 0. Our y-intercept, I'm trying to be color coordinated here. Our y-intercept, that's when x is equal to 0, and we plug that in. We have 0 minus 2 squared times 0 plus 2 times 0 plus 4. That is 4 times 2 times 4. That's 16 times 2, which is 32. So that gives us the point 0 and 32. And then let's see what our extreme end behavior is. If we look up here, we have 2 plus 1 is 3 plus 1 is 4. So that is an even, and it's positive. So we know that both ends point up. All right, well, let's get down to it. Let me put in some hash marks here. Now notice that our y-intercept is at 32. I'm going to do this little thing that we do to kind of compress down the graph, and I'm going to go ahead and throw us up here at 32. Okay, so let's graph our points here. We have 2, 0, negative 2, 0, and negative 4, 0. We have a y-intercept of 0 and 32. So you see we'll be able to connect these dots. In fact, I think I shall. That's a definite thing that's going to happen. And then let's take a look at our end behavior. From our leftmost point, it's going up. From our rightmost point, it's going up. And you can see here that we just need to find out what's happening in this area. So it looks like f of a negative 3 would take care of that. So negative 3 minus 2 squared times minus 3 plus 2 times minus 3 plus 4. So this gives us 25 times negative 1 times 1 gives us a negative 25. So I'm just going to come down here and throw this point in here. And in this case, I'm just going to call this point negative 3, negative 25. We could do the cool little shorten it up and put the point over here, but this is good enough for government work. Oh, it's really hard for me to draw straight sometimes. Okay, let me try it this direction. All right. We could also tell by looking here, let me just reinforce the idea of passing through and bouncing. We can notice that this guy is even, and so it bounced, it came and it came back. It did not pass through. This guy passed through, and this guy also passed through. Okay, cool. All right, so I think what I have is another example. There's going to be some you-dos for you, but let me get a couple more examples in here. This one is f of x is equal to negative x to the 5th plus 5x to the 4th plus 4x cubed minus 20x squared. So this is our first one that is not factored. So first we're going to need to factor it, but let me stop for a moment and talk about the extreme end behavior here. Because this is already FOILed out, it's already multiplied out, we don't have to count up anything, we don't have to do anything. We simply look and we can see that this is an odd negative. And so it is going to be up on the left and down on the right. Okay, so let's factor this guy out. Now, first things first, I'm just going to write it again, a little bit neater this time if possible. And first thing we want to do is we want to factor out the common, whatever's common. And if your leading coefficient is negative, you need to factor that out too. So I'm going to factor out, sorry, I just noticed my mistake. These should be x squares. Okay, so I'm going to factor out a negative x squared. And when I take a negative x squared out, I'm left with an x cubed. Okay, sorry. Minus a 5x squared minus a 4x plus 20. Okay. And now let's take a look at this again, and we notice it's 4 pieces, and if you worked on your factoring stuff, you know that we're looking for equations with 4 pieces because we can factor those by grouping. So I'm going to split this guy in half, and what can I take out of the first half? I can take an x squared, and I'll be left with an x minus 5. That's my twin, so I'm going to write it down again. And what do I need to multiply x minus 5 by to get negative 4x plus 20? That would be a negative 4. So far my factors are x minus 4, or x squared minus 4, x minus 5, and don't forget this guy, negative x squared. But this is not fully factored yet because we have the difference in squares. So let's get that fully factored form here. F of x is going to equal negative x squared times x plus 2, x minus 2, and x minus 5. Now, another thing that you can do pretty easily from the general form, remember this is general form, we talked about it last time. So another thing we can do easily from general form is to find the y-intercept. Just sticking it in prevents you from having to do any work. And when I plug in zeros for all of these x's here, I get 0 for y. So my y-intercept is 0, 0. Now, getting my x-intercepts, I set each one of these factors equal to 0, and there is 1, 2, 3, 4 factors to set equal to 0. So I have x is equal to 0, x plus 2 is equal to 0, x minus 2 is equal to 0, and x minus 5 is equal to 0. So our x-intercepts are going to be 0, 0, negative 2, 0, 2, 0, and 5, 0. All right, so we can just get to graphing this up. Let's plot our x-intercepts first. We have 0, 0. We have negative 2, 0. We have positive 2, 0. And we have 1, 3, 4, 5, and 0. Our y-intercept is also 0, 0. So I'm just going to put it there. Notice we don't have any levels here. There's no points for us to connect to, and you cannot draw a straight line across the x-axis. That is not allowed. So we're going to have to be figuring out some stuff. Let's put in our extreme end behavior. From the leftmost point, we're going up. From the rightmost point, we're going down. And now it looks like we're going to have to do some work here. We need to find out what's happening here, what's happening here, and what's happening in this area. So first, let's take a look at what's happening at f of negative 1. Now, it doesn't matter which way you go. You can plug it into the factored form. You can plug it into the original form. It doesn't really matter. Since it's plugging in a negative 1, it's making it pretty easy. So I'm just going to plug it in here into the general form. I might plug in something different when I get over here to 3 or 5. I'll probably use the factored form here, but let's see here. So we have negative of a negative 1 plus 5 times negative 1 plus, oh, I totally screwed that up. Sorry, y'all don't pay any attention to me. That's 5 times negative 1 to the 4th power plus 4 times negative 1 to the 3rd power minus 20 times negative 1 squared. So this is going to be 1 plus 5 minus 4 minus 20. So let's see, negative 20. This is so terrible. My arithmetic is awful some days. Some days it's great. So negative 24 plus 5 is negative 19 plus 1 is negative 18. So it looks like, unless I made a mistake, which I should tell you guys, my arithmetic is horrible, that should be our point there. So let's just put it in here. So we can put these together. It wouldn't look quite that thin. It would look a lot nicer, but I'm just not going to mess around with it here. Let's do f of 1. Plugging in 1, we'll have -1 plus 5 plus 4 minus 20. So let's see, that is -12, I think. -21 plus 9 is -12. That seems very reasonable. So here, let's put that guy about right here. You want to definitely make it, you know, higher up than this guy. And now let's see what's going to happen in between here. Now we could come over here and we can make some guesses. Now my guess is that it's going to be a positive number because I see that we're going to bounce at 0, but the rest of these are just passes. The rest of these are going to just pass through. So we know that it's doing this, and we know that it's doing this somehow. So let's figure this out. 2, 3, let's do f of 4. And I'm going to put it into the original equation here in the factored. So 4 squared times 4 plus 2 times 4 minus 2 times 4 minus 5. And let's see here, I have -16 times 8 times 2 times -1. So let's see, this is, looks like positive 256 because 16 times 16 is 256. I know that from my computer programming days. So this guy goes up here. Come down, and this is 4 and 256. And there's our picture of that graph. Looks kind of crazy. Okay, one more for me, and then I'm going to have you do one. X minus x cubed. This one looks really straightforward, but I want to point out a couple of things here. And the first thing is that you want to put this equation in order before you factor it, so you can factor out the negative and everything. So the first thing I'm going to do is rewrite this as -x cubed plus x. And here I can take out a -x, and that leaves me with an x squared minus 1. And so that factors -x, x plus 1, x minus 1. So let's find our x-intercepts. Our x-intercepts are going to be 0, 0 from this, -1, 0 from this, and 1, 0 from the last factor. And then if, and this is always, if you have an x-intercept of 0, 0, you automatically have a y-intercept of 0, 0. Now you could go plug in 0 there and see that, but I want you to start thinking about that and understanding how those two relate to each other. And then our extreme end behavior is negative, odd. So we have odd and negative. Remember, it's already in this form. You could get the odd and the negative from here too by counting 1, 2, 3, or you could see that it is 3 with a negative in front. Either way that you see it. Okay, let's graph this guy real fast. Let's see here, we have 0, 0, 1, 0, negative 1, 0. We have a y-intercept also that is 0, 0. And our extreme in behavior says odd negative, so it is up on the left and down on the right. Okay, so we've got our work cut out for us. To finish this up, we need to find f of negative 1/2, and we'll also find f of positive 1/2. That's going to give us that information in between there. So I'm going to have a negative 1/2 times negative 1/2 plus 1 times negative 1/2 minus 1. This gives us positive 1/2 times another positive 1/2 times a negative 3/2, and that gives us a negative 3/8. So somewhere, let's call this 1. So somewhere about here could be negative 3/8 if we were so inclined. And then let's do this guy here, negative and a 1/2. 1/2 plus 1, 1/2 minus 1. This gives me negative 1/2 times 3/2 times another negative 1/2. Gives me positive 3/8. And making this guy 1 and negative 1. Here we go. Now that's the prettiest one, but that was also the most simple one to do. It was the most straightforward, even though it might have appeared to be a bit frightening. Okay, let's have you one to do. Let me remind you that I told you about this last class, that what I like to do in my classroom, and I'm going to try my darndest to do it here, is to give you problems to practice during the lecture. Now, the best thing about having a recorded lecture is you can always do this, right? I can write down a problem and you can pause and work the problem, and then you can unpause and you can watch me work it out and you can check your work. So it's a great benefit. Okay, so I'm going to give you a couple minutes, literally going to give some dead space here for you to work on this. When the space gets too long for me to sit here and wait on you, I'm going to go ahead and start, and I'm going to work the problem. If you're not ready yet, when I'm done pausing, I want you to pause and finish the problem. Okay? All right. Of course, I gave you one you needed to factor. So let's get on with it. Okay, so if you haven't finished yet, please pause the video now so you can finish the problem and then pick back up. But let's go ahead and solve this here. Okay, so first we need to put this in factored form. We can pull an x out, and we're left with x squared plus 2x minus 8. This factors as x plus 4x minus 2. If you're still struggling a bit with factoring, just keep on practicing. Okay, and now let's go ahead. It's in factored form here. Let's get our x-intercepts. Well, we have a solo x there, so we know we're going to have 0, 0. We have negative 4, 0, and 2, 0. Let's find our y-intercept. That's easy because we've already found our x-intercept being 0, 0, so we know we have a y-intercept of 0, 0. And let's look at our extreme end behavior here. Looking at the original, looks like we have odd and positive. That means it is down on the left and up on the right. It goes in a upward slope as you read it from left to right. All right, let's graph this real quick. Putting in our x-intercept 0, 0, negative 4, 0, 2, 0. Awesome. Our y-intercept is also 0, 0. Okay. No big deal. We just need to find f of 1. And let's find f of negative 2. That seems to be good enough for me. So f of 1, I'm going to use the original equation. So we've got 1 plus 2 minus 8. Negative 8 plus 3 is negative 5. So we have the point 1 and negative 5 on the graph. Oh, I didn't sketch in my end behavior. Let's go ahead and do that. It's going up here and down there. I talked about it but didn't sketch it in. Trying to finish this guy up. So there we go. And then f of negative 2. I'm just going to do it this way. Negative 2 cubed plus 2 times negative 2 squared minus 8 times negative 2. Might have been easier to do it in the factored form here. Let's see, negative 8 plus 4 times 2 is 8 plus 16. Oh, those canceled out, so we got 16. So we have negative 2 and 16. So we go negative 2 all the way up here. We'll call that 16. And here we go. So I hope yours looked like this. Okay. Let's do another one here. I like I said in one of my other lecture videos, I like to give lots and lots of examples. So f of x is equal to 4x cubed plus 10x squared minus 4x minus 10. Okay, so we need to graph this, and it is already 4 pieces. So let's factor it. Okay, we have to factor it completely, right? So we take a look at the first half, that left-hand side. What is the most we can take out? We can take out a 2x squared, and we'll be left with a 2x plus 5. That's our twin. Going to write it down again. What do we need to multiply 2x plus 5 by to get negative 4x minus 10? That would be negative 2. So we have 2x squared minus 2 times 2x plus 5. Now I just noticed that I could have pulled a factor of 2 out at the beginning, but doesn't rightly matter. Let's keep on factoring here. I can pull a 2 out of here, and I have x squared minus 1, and our 2x plus 5. Keep on going. We have 2 times x plus 1, x minus 1, 2x plus 5. So there is our factored form of our function. Our x-intercepts are going to be -1, 0, +1, 0, and -5/2, 0. Our y-intercept is 0, -10, and I got that quickly by doing it right here. Way easier to plug 0 into it in general form because everything with an x falls away and you're just left with the y-intercept. Okay, and our extreme end behavior here is going to be odd positive. I'm sorry, everything seems to have been odd, but maybe one of the last examples won't be odd. I don't know why they're all odd, but seems as though they're all odd. It'll be all right though. I think you guys will get the gist. Okay, so let's go ahead and graph this. Let's see what we got here. All right, so we have -1, 0, 1, 0, -5/2, 0. That's 2.5. Sketching in our y-intercept, 0, -10. Our end behavior here, odd positive, so it is coming down from the leftmost, up from the rightmost, and we can connect these dots right here because we have a point in between those two x-intercepts to connect to. Kind of crappy. I don't know why I felt like I had to fix it, but I am going to fix it. Okay, and then finally we need to find out what's happening over here in this spot. It looks like f of -2 will do the deal. So we're going to have 2 times -2 plus 1 times -2 minus 1 times 2 times -2 plus 5. So let's see what we got. 2, -1, and a cat. A cat's butt, sorry. 2, -1, -3. I can't believe my cat just absolutely did that. I'm so sorry. And 1. So let's see what we have here. We have +6. Right? Yes, so we have the point -2, +6. So let's get us some. Okay, awesome. I have another you-do for you to do. F of x is equal to 3x to the 6th plus 6x to the 5th minus 12x to the 4th minus 24x cubed. Okay, so you're going to have to factor this guy. I'm going to give 2 minutes for you to start working on it. Maybe I'll give 3 minutes. This one will take you a little bit extra to get it factored. Be sure to factor out the common factor and then take a look. Remember, if it's already 4 pieces, you can just split it and factor it by grouping. I'm going to give you about 1 more minute. Okay, let's factor this guy. So if you're not done yet, just pause and come back. All right, so let's take a look at what we've got here. We have 3x to the 6th plus 6x to the 5th minus 12x to the 4th minus 24x cubed. Let's see, it looks like I can pull a 3x cubed out of everything, and that was going to leave us with an x cubed plus a 2x squared minus a 4x minus 8. And then I notice here, because everything's pretty so far, this far in chapter 5, it's going to get ugly at the end, but right now we're dealing with pretty factoring. And so we see that we can split this guy in 2. So what can I take out of this first half? That would be an x squared, and that would leave me with an x plus 2. That's my twin. I'll write it down again. What do I need to multiply x plus 2 by to get negative 4x minus 8? That would be a negative 4. So far my factors are 3x cubed, x squared minus 4, x plus 2. So let me go ahead and finish this up with the factoring. This is 3x cubed times x minus 2, x plus 2, another x plus 2, and we want to write this in the most simplified way, the most sophisticated and simplified way. So that's going to be 3x cubed times x minus 2 times an x plus 2 squared. This is the full factored form here. Okay, now we can tell a couple of things before we have to do any work. What's the y-intercept? Y-intercept, 0, 0, straight up. What is the extreme end behavior? The extreme end behavior, if we look here, it is positive and even. Oh, yay, I did one. So it's positive and even. Yay, that means both ends go up just like an x squared. And then let's get our x-intercepts. Our x-intercepts, well, of course, we've got 0, 0. We got that one from this 3x cubed term. We also have 2, 0 and negative 2, 0. So let's graph this. I have 0, 0. I have 2, 0. I have negative 2, 0. And I have my y-intercept is also 0, 0. So it looks like we're going to have to figure out what's happening in a couple of places, but not terrible. Our extreme end behavior is up from, oh, I thought I changed my color. I did not. Up from the left and up from the right. And it looks like we're going to need to find what f of 1 is equal to and what f of negative 1 is equal to. I do f of 1, I have 3 plus 6 minus 12 minus 24. Let's see there, that's 9 minus 12 is negative 3, so this is negative 27. So 1 and negative 27, I'll stick that right here. And then we'll plug in negative 1. It doesn't change the 3. It does change the 6 to a negative. It doesn't change the 12. It does change the 24 to a positive. So 24 minus 12 is 12. Minus 6 is 6. Plus 3 is 9. So if I did not screw any of that up, then this point here is going to be negative 1 and 9. Okay, I have one more example for us. And it's going to look ugly, and you're going to be glad that I did this example. So it is 3/2 x cubed minus 15/4 x squared minus 6x plus 15. And frankly, I chose to do this problem just so I could get you over freaking out about all of these fractions. So the first thing first is we need to make these all common denominators, and the denominator is 4. So this can be rewritten as, so what am I going to do? I'm going to multiply this guy by 2 over 2, this by 1 over 1, this by 4 over 4, this by 4 over 4. Okay, just reminding you of what I'm going to do here. So this is going to be 6/4 x cubed minus 15/4 x squared minus 24/4 x plus 60/4. Make sure I did that all right. Yes, I did. Excellent. Okay, now we don't go through here and simplify this because you will have defeated your purpose. Now what common can we take out? Well, it looks like we can take 3/4 out of everything. We can factor out a 3/4. So if I factor out 3/4, I'm going to get rid of all those fractions. It's going to be like magic. It's going to leave me with 2x cubed minus 5x squared minus 8x, because 3 goes into 24 8 times. Sorry about that. And plus 20. Let me double check my math, make sure I'm not screwing anything up. Looks good. Okay, now we get to factor this middle piece. And we're getting kind of used to these pieces of 4 here. So what can I take out of this? I can take an x squared out, and I'm left with a 2x minus 5. That's my twin. Write it down again. What do I need to multiply 2x minus 5 by to get negative 8x plus 20? That would be negative 4. So far we have 3/4 times x squared minus 4 times 2x minus 5. So full factored form here is going to be 3/4 times x minus 2, x plus 2, 2x minus 5. Awesome. Okay, let's go ahead and get our y-intercept. We can get that quick and easy off the OG here. If I plug in zeros everywhere, I get a 15, so I have 0 and 15. My extreme end behavior is odd positive. So that's going up from the left, going down on the left and up on the right. And then let's find our intercepts here, our x-intercepts. We have 2 and 0, negative 2 and 0, and ironically again, and this time it's positive 5/2 and 0. So let's graph this. This is our last one. Let's do a little make this guy 15. And plot our points here. We've got negative 2, 0. We got 2, 0. We got 5/2, which is 2.5. Ooh. Ooh, we're gonna have to do some dirty work. Get that one answer in between there. Let's get in our end behavior. Down from the left, up from the rightmost. I forgot our y-intercept. Let me put that in up here at 15 so I can connect these dots. And then I've got to find this in here. And it has to be between 2 and 2.5. Okay, so I need to find f of, this is 4/2 and this is 5/2. So we can just pick a number in between 4/2 and 5/2. So let's make this fourths. This is 8/4. And what would the next one be? 10/4. So the number we need is 9/4. So I'm going to find f of 9/4. So let's see, 3/4 times 9/4 minus 2 times 9/4 plus 2 times 2 times 9/4 minus 5. Oh my goodness. Okay, so let's do this here. So we have 3/4. Now, of course, if you have your calculator handy, you could do that too. So 2 is 8/4. So 9/4 minus 8/4 is 1/4. 9/4 plus 8/4 is 17/4. And let's see here, that makes this guy 9 halves minus 5, which is 10 halves, which gives us negative 1 half. So let's see what we've got there. Go across the bottom and go across the top. Let's see, 3 times 17, it's going to be negative for sure. 3 times 17, 1, carry the 2, is 61 over 4 times 4 is 16, times 4 is 64, times 2 is 128. So 61 divided by 128 is a little bit more, no, a little bit less than a half. A little bit less than a half. That point right there is 9/4 and negative 61 and 1/28. Okay, we did it. Yay! All right, you survived. Okay, have a good day.